So today we're building off of, Leighton, if you want to catch the front light, that would be very helpful. Today we're building off of, what we've been talking about, right? Today's lesson is titled, 8.4, grafting ax squared plus bx plus c. Now we have seen this form before, right? This is just the polynomials that we've talked about. Something like x squared plus 3x plus 2. That's all that it means by ax squared plus bx plus c, where we have numbers in each of these spots, okay? All of the things that we've graphed with our parabolas so far have just been y equals ax squared. That's been the form. So today we're going to look at how things change and what happens when we have this bx and plus c at the end. Okay. We also have had y equals ax plus c, right? We've dealt with this plus c before. And what does that c value at the end do to our graph? What does it do? Yeah, changes the y-intercept. It moves us either up or down. So really the only thing we're adding is this bx right here. Okay? We know that this a value makes our graph face up or flip down. That a value also helps us decide if our graph is narrow or wider, right? So we know what that a value does in front. We know that the c value moves us up or down. So we need to find out what that bx does to our graph. Our learning targets for today is that we will be able to find the axis of symmetry in the vertex of the graph that's in this form right here. So we're going to need to be able to find the axis of symmetry in the vertex. It's not going to be quite as easy as it has been in the past. We're going to learn a couple formulas today that will help us out with that, but it's pretty familiar with some things that we've done already. And then not only will we be able to find the axis of symmetry in the vertex, but we also will be able to graph equations in that form. So let's look at a couple properties of the graph that is in this form. Y equals ax squared plus bx plus c. Just like we had earlier, and like we talked about, the graph, like it says in this first bullet point, if our a value up front is greater than 0, the graph opens up. Right? If it's positive, the graph opens up. If it's negative, the graph opens down. We already know that. The y-intercept is c. So just like Leighton said, we know that end c values are y-intercept. That's still true. That's things that we talked about. Now here's where things change a little bit, okay? When we are finding our vertex. The x-coordinate of our vertex is found by this little equation right here. The opposite, or negative b over 2a. Right? It's easy to say, and I shouldn't have said it, negative b over 2a, but we really should be saying the opposite of b over 2a. Because if b were a negative value, if b were like negative 4, then we would not put negative 4 in for b. We would just put positive 4. So we need to be in the habit of saying the opposite of b over 2a. That's how we find the x-coordinate of the vertex. The axis of symmetry, we find, the axis of symmetry is the same as our x value, or x-coordinate, right, of the vertex. So we find the axis of symmetry the same way that we find the x-coordinate of our b value. So what I would have down in your notes is, you can draw the picture if you want. That's good, and those first 2 bullet points are good. We already know those first 2 bullet points. The new thing here would be right here. That our x-coordinate of the vertex and our axis of symmetry is found by opposite of b over 2a. So let's look at an example. find first the axis of symmetry, and then find the vertex of this graph. Correct? Well, let's start with the axis of symmetry. We know that the axis of symmetry is opposite of b over 2a. What is our b value? Somebody need to tell me, what is our b value? 8. So the opposite of b would be negative 8 over 2, what? I was going to say, that sounded like Siri. Our a value is 2. So then our axis of symmetry would be x equals negative 2. We simplify that. X equals negative 2. Now our vertex. We know what the x value is, right? Because it's the same thing as our axis of symmetry. Our x value is negative 2. How would we find our y value? Well, that's very easy to do. But remember, our c value, or this negative 1, is our y-intercept, which it could be our vertex, the y value of our vertex as well, but it isn't always the y value of our vertex. I like the idea. What do we think? How can we find the y value? We know that the x value has to be negative 2. How can we find the y value? If I told you, we have this equation up here. If I told you find the value of y when x equals 5, what would you do? Yeah, we plug 5 in for x. So what we're saying here, really, is that the x value is negative 2, and we need to find our y value. So what should we do with that negative 2? Right, plug it into the x, and we'll find our y value. So 2 times negative 2 squared plus 8 times negative 2 minus 1. First, we need to take care of our exponents. So negative 2 squared would give us 4. 8 times 2 is negative 16 minus 1. 8 minus 16 minus 1 give us negative 8, negative 9. So at negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, sweep it in. Right here would be our y value of our vertex. That would be our vertex right there, negative 2, negative 9. Now it makes sense. You see our y-intercept is negative 1, and since we have a positive a value, we know that our parabola is facing up. That makes sense, doesn't it? Right there. Let's sketch our graph. Do we have any questions on that one? We find our axis of symmetry and we find our vertex using those equations that they gave us. And then to find the y value of our vertex, we need to plug our x back into our equation. Let's see. We will skip over this example. Graph y equals, well, because we just graphed the last one, right? Let's go over domain and range of this one, though. What is the domain? What are our x values, possible x values? Yeah, anything could be an x value, all reals. What about our range? What are our possible y values? Something happens at the y here at negative 9, right? This is where our graph starts, here at negative 9. Yeah. So y is greater than or equal to negative 9 down here, but it could not equal negative 10, could not equal negative 11. Anything above negative 9, we are all set. A couple new terms. I think it's our last new term, an example, and then pretty close out of time, so we'll start the worksheet. Maximum and minimum values. Okay, we already have been talking about our vertex and stuff, so now this is just getting a little bit more specific with our vertex. The y-coordinate of the vertex of the graph is the maximum value of the function when a is less than 0. Okay? So when we have a parabola that's flipped upside down, like this one is, then our maximum value would be the y value of our vertex. So let's say that this is at 2, 7. Our maximum value, if they ask what is the maximum value, it would be 7. That top value. We use our vertex to find it. The minimum value of a function would be, well, as you could guess, the smallest value of our function, or of our parabola. We also find that smallest value by looking at the y value at our vertex. So let's say that this is at 2, negative 6. The smallest value, or the minimum value of this parabola would be negative 6. So we're using the vertex, but we're just getting a little bit more specific with what is that vertex? Is it the minimum? Is it the maximum? What is it exactly? Questions on minimum and maximum? Or does that seem pretty easy? We're good with vertex, so this shouldn't be too far of a stretch. Tell whether the function f of x equals negative 4x squared minus 24x minus negative 15 has a minimum value or a maximum value, and then find it. So I think an easy way to do this would be to just quick sketch a graph. Why don't we find the vertex? So if we're looking for the vertex, our x value and our y value, how did we say we would find the x value of our vertex? What new thing do we just look at? Yeah. Over 2a. Amari, what is our b value in this equation right here? Yeah, negative 24. So we take the opposite of that, so it's positive 24 over 2. Our a value is negative 4. 24 over negative 8 would give us negative 3. And then how do we find the y value, Joe? Remember? Yeah, we have negative 3. Plug in negative 3 for us. Good job. Is there another calculator? Can someone plug that in? I'm going to try to solve it, but you got to plug it in to check. 9. Get it? Someone get it? The y value here. So when we plug x in, or we plug negative 3 in for x. Looking for our vertex, anybody plug that in and get it? Negative 36. Let's substitute the positive 36. I think it's 17. Maybe. Come on, just plug that in. Somebody. 17. All right, 17. now we have a negative a value. So our graph would be facing down. So with this vertex here, this point, would this be our maximum or our minimum? Yeah, it'd be our maximum. It's our tallest, highest value. So it would be a max. And then what is the value of our maximum? What do you think, Skylar? Oh, see, I would call you Lurk. Huh? So I would have called you Lurk. If I say, oh yeah, that's okay. Skylar, did you hear what Lurk said?
Yep.
What is it? Yeah, good job. Maximum value is 17. Good job. Not too bad. We only have like 9 minutes left in class, so I'm going to give you the worksheet. But where's the worksheet? Where did I put it? Oh, did I forget to copy it? I could have. Maybe. Unless I threw it in here. Minutes. Should I make the copies and we can get it started, or should we just save it and work on it tomorrow?